Hello, and I'm just going to set a timer so I can keep an eye on the time. Hi, thank you for coming to my talk today. It's Secure, Modern and Simple Dependency Management with PDM and Friends. And just before I kick off, I'd like to say a big thank you to the organisers of this conference. Putting on an event of this scale and at this quality is no mean feat, and I think that all the organisers, contributors, volunteers, everyone really has outdone themselves this year, so thank you to Python. Now, I'll dive into the talk, but before I do that, it's probably worth explaining who I am and why I'm stood here in front of you today. My name's Weldon. I'm a full-stack cloud software engineer. You can get a rough idea of the sort of flavors of the technologies that I use from some of these logos here. You'll notice as well that I've included the latest album cover by The National, Laugh Track, if anyone's heard it. I know that's not technically kind of like a programming technology, but I do listen to The National to write about 98, 99% of my code, so it seemed unfair not to include their new release here. But moving on, I'm based in central London, and it gives you a little flavour of what it feels like and how cool it is there, just based on that graphic there that looks like it was taken from the Shard or possibly generated by AI, who knows. And I often like to make a little bit of a joke here when I'm giving a talk, especially not in the UK, but also particularly when I am in the UK, because us central London residents aren't always the most regionally popular people going around the country. To give you a flavour of that, when I was here last year, I talked about this place, the pub. And this is one of my favourite pubs. It's at the top of my street. If we've got anyone here who's ever studied at UCL, I wouldn't be surprised if some people here have had a pint there. Now, if you allow yourself to cast your mind back to this conference last year, I gave a talk, and if we're trying to remember what it was like, it was in that weird sort of vivid 43-day hallucination we all had where the Queen died and Liz Truss was the Prime Minister. But at this talk, when I was making this joke, I thought, well, what do people think of when they think of central London? And I used this graphic here to explain what it's like living in central London, that a pint costs an extortionate amount. And I did add a little bit of exaggeration to that, maybe added £1 or so on for comic effect and stuff. But, what goes around comes around. And I was in Tiny Rebel here just the other night and ended up paying almost £8.50 for a pint in Cardiff. So I'm not really sure what the I'm not really sure what the punchline is to the joke this year, but I know that someone somewhere is laughing at us. So moving on. As a little bit of background as well, I work as an independent contractor. My past is academic. I did a kind of broad range of degrees, stayed at university for about 10 years before I managed to escape. I was previously working in a consultancy, working mostly in kind of defense and intelligence and some kind of infrastructure projects with AI, ML, that kind of stuff. These days, I work for an investment management fund in a kind of very large City of London corporation. I work with the quants and we build tools to inform sort of model making and investment decisions. I've decided not to name them again this year, not being mysterious for any reason, but just in case my employers are watching, I'm here as a guy that enjoys talking about Python in a kind of rainy Cardiff on a Sunday afternoon. So, moving on, I'm going to talk to you about this tool here, PDM, which originally stood for Python Dependency Manager. You can check out the project at PDM on GitHub, and the creator, or the kind of initial founder, Frost Ming, has a really interesting blog and publishes lots of articles that are worth checking out. Moving on, I'm going to hopefully cover a bit about how imports work, what are dependencies generally, how might you want to use PDM and why, and also have a very quick look at how dependencies in your code can make your code vulnerable. Now, I don't want to be exclusively accused of this. It's very tempting when a new tool comes out to say, hey, how cool this tool is, everyone should use it, and then forget about it 10 minutes later. I'm guilty of that, I know. This isn't a comprehensive overview of all things PDM. It's not an advert for the project. I work on a few as a contributor to a few plugins, but I'm not like an evangelist for PDM here. It's just a bit of an analysis of a useful tool. So, before we dive into PDM fully, I want to go back to some of the basics about Python. So everyone here, I'm sure, will have written this piece of code in the past. You open up a REPL in Python, you type hello world, and boom, you've just written your first Python program. There's quite a lot going on here. We've had to install Python, so we've told our command line to associate this word Python with an executable. The Python executable's taken a bunch of symbols that we've sent it, and it's tokenized these, it's worked out what it's meant to do, and it's found that this print word here matches to the print callable that exists in Python. It's taken the arguments that we've supplied to it here, this string hello world, it's matched the arguments that we've provided with the parameters of Python's print function, and it's printed something to standard out, which is hello world here. So there's a lot going on here under the hood. And, we've had to do several things that you might not think about initially when you first run your Hello World tutorial. So let's imagine that we want to build a slightly more complicated app. We're pretending to be a dog here that will bark. And now I've got a slightly more complicated program. I've turned my one file on the REPL, or my one line of code onto the REPL, into 3 files. So I've created a package here with this init.py file. We're now also, as a result of that, able to use code from one module inside of another module. And so here, on this line, when we say, import utils, we've actually told Python to, hey, go look in the file system, open a file for me, execute what's in that file, and make it available to me at this namespace called utils, which is quite a lot of things that are happening under the hood. Now, let's move on. Async's cool. Let's make it async for some reason. I'm not sure why, but bear with me for this example. Now, we've looked here. We've just made another import async.io. But where's this async.io come from? There's no async.io.py file in my file system here. At least I don't think there is. Let's check there isn't. So where's this come from? I have no idea. Now, let's also imagine that we want to make our program a bit jazzier, and so we're going to use this library Rich, which, has everyone heard of Rich? Great. If not, use it. I'll talk about it in a minute. So now I'm going to use Rich to add some color to my program, and I'm also going to say that this dog, like every dog I know, can be in a couple of different moods. It could be yappy, it could be growly, or it could just want to say woof, woof. So we've imported Rich to make our program a bit prettier, but bummer, there's an error. Module not found, no module named Rich. So we forgot a step here, didn't we? And I think, as everyone will have guessed, that step usually is something like pip install Rich. So pip is a successor to lots of earlier tools that existed in the sort of bad, dark days of Python packaging, like easy install and distutils and various other things that they're basically designed to, well, not designed to cause pain, but a lot of people, if you've been working in Python for a long time, will remember these tools not necessarily fondly. Rich, it's an excellent package for CLI formatting and having rich text in your terminal. And so we've told pip here to install Rich for us, and now we're going to run our program and say, oh, bummer, what's happened? Syntax error. What's it complaining about here? This match statement, it doesn't like it, but match is valid in Python. It's perfectly fine to use. What's happened? Oh, I'm using Python 3.9. Let me check. When did match? It was Python 3.10 that match statements came out in. Bummer. Okay, that's why my program's not working. How do I fix this? Well, it comes back to our kind of hello world example, what we were doing here, when we said that we've told our command line to associate the word Python with a particular executable. That's a binary file that our computer can run. And we need to make sure that that executable, though, is at the right version. So, there's more going on here than we thought. So let's imagine we've installed Python 3.10 or 3.11, the latest version, and we run our program, and finally we've got a yappy dog, and we couldn't be happier. Everyone loves a yappy dog barking in their ear all the time, don't they? So we get that kind of sweet satisfaction of our code running, and it running well. So moving on, though, before we sort of kind of start thinking about our program in some more detail, something has changed in our program here, hasn't it? This line, import Rich. I can't say anymore that I wrote all the code that is being sort of used inside of my program, can I? Who wrote this bit of code here, Rich? There's an important, has it been written by good people, or are they maybe baddies? So, Now, I don't know Will McGugan personally, at least I don't think I've met him, but I follow him on Twitter, and I actually messaged him to make sure he was happy with me putting his face up on this slide, and he is. Will is great. He's a great guy to follow on Twitter and publishes lots of interesting stuff about Python, and also lots of really delicious-looking meals that he seems to cook with his partner up in Edinburgh. So, yeah, he checks out, I think. You can read about him on his blog and about the Rich project generally and textual. He gets a big tick, definitely a goodie. Will can run some code on my computer, that's fine, I trust that. But what if I was to import another package, say something else? Now, I've called this something else because it's true to my Manchester roots, and also, thankfully, there isn't a something else package yet. So I'm not incriminating anyone here, but we don't necessarily know that much about this other package, something else. And what if it was written by this guy? I think I do recognize that guy, actually. He's been in the news, so you see him around a lot. So yeah, I'm not going to run code from him. He's a baddie, so I definitely don't want to be running something else. But let's just think about some of the points we've covered so far. There's a lot going on. So we've got some questions as a result. First off, how is Python finding all of these packages and these modules? And where do these ones that I can't see live? So also, I need to think at the same time about how do I know I'm using the right version of Python? Where do packages come from in the first place? And finally, how can I know for certain that a package is safe? Or at least kind of hope that it's safe. So let's answer these questions, and we'll introduce a couple of tools along the way. So the first question about how is Python finding some of these packages? Well, let's answer the second part of this question first. Once we've got these packages that we can't see, where do they actually live? Python has a really brilliant inspect library that if you're a sort of if you're a low-level systems programmer, you probably absolutely hate, which allows us to inspect lots of objects at runtime. So we can use this useful little function or this useful library, inspect, to get the source file and tell us, where is this code written, where is its source file at the moment. And if we look at that, we can see user lib Python 3.10 inspect. But if you look at that file path, actually, that's a really, if you know anything about Linux sort of system and like file directories and stuff, that's quite a sensitive location there. I'm surprised that I'm installing stuff into it. And that's actually because this is my system Python. So you really don't want to go messing around with your system Python if you're using like Mac or Linux. This is something that's quite important to the operating system. So how do we make sure that we're using the right version of Python and that it's installed in somewhere appropriate for us to kind of go messing around with it? And the short answer to that is this tool, pyenv. I'm sure lots of people have heard of it. People familiar with it mostly, hopefully? Yeah, quite a few. Basically, if you're working with Python a lot, you'll want to install different versions and know which version you're using. Pyenv just does this for you. Use it, it will make your life better. So we can just use a simple command here, like install a new version, the latest version of Python 3.11.5, and say I want to use Python 3.11.5 locally. Uses these things called shims. We don't need to know about shims too much. So if we assume that we've installed the latest version with pyenv, and look now, where does this inspect file live? Well, you can see pyenv seems to have created a special part of my operating system or my home directory here to store different versions of Python, and we can see now we've got this kind of lib file that stores the standard library. So that's where a lot of our standard library files live. Now we can actually go kind of poking around in this directory, have a little look. So I'm just here writing some Python code to tell me what other files exist in that directory there using pathlib. And here we can see now that we've got basically all of the different standard library packages that you can see here, like abstract base collections, async IO that we were playing with before, and so on. I might have curated this list slightly. That is not what happens if you ordinarily print it here. But we see here, we've got this site packages directory. Now, that's different because that's not a Python file. That's a directory. So what's in there? Let's have a little poke around in there. And again, we use pathlib. And we've found now our first non-standard library package that exists somewhere in our Python. And that package is pip here. Now, you might say, hey, is pip not in the standard library? And it's not, no. It was introduced, really useful tool, written by Ian Bicking back in 2008. It rationalizes a lot of the other kind of previous packaging utilities that came before that. And there is a standard library package, or module, sorry, called ensure pip, which is part of the standard library that we can use. So by default, pyenv will install pip for you. So that's a good way. And it's really important that we have these kind of, so we could begin, installing packages into our site packages directory using pip, but it's probably not a good idea. If I really want to reuse Python 3.11.5 across 6 or 7 different projects, like I could install a package in one project that then becomes available to all of them. What if it's the wrong version? What if I don't want that package? What if it's been written by a baddie, that kind of thing? So we need a way of isolating these packages that, on a particular per project basis. And the way we do that at the moment is by creating virtual environments, which has a kind of localized Python executable in site packages. Again, it was also developed by Ian Bicking around this kind of same time in 07, 08. So we can, we still use the same Python executable that's coming from PyEnv here. It just creates a symlink, or in Windows speak, like a shortcut to that particular version of Python. But this virtual environment allows us to have this kind of hierarchical way of resolving package names in a given environment. So we say first look in the venv, then look in the standard library, that kind of thing. So if we just assume for a minute that we've created a virtual environment and we've activated it, let's look at how does this hierarchy work? Well, before we do that, let's just quickly check that we know what the difference here is between a package and a module. So this is actually like a really straightforward and fundamental difference, but it's one that still confuses me all the time. The way you have to remember it is that everything, including a package, is a module. Packages are modules, but all modules have a name. They, by definition, have to have a name, and they're all of the same type, which here is module. Now, the code inside of a module is executed when the module is imported, and that module ends up in this big dictionary-like thing here, sys.modules. And you can inspect that at runtime by importing sys and looking what's in sys.modules. Packages, though, they're special. They're a special kind of module, and they still have the same type, they still have a name, but they also have this path attribute, dunder path, and that's important. We'll come to that in a second, but the thing to remember as well about packages, and the reason why we have to have this init.py inside of packages that we write, is because Python needs something to load and run at import time. So for a package, it's this init.py, which gets executed at runtime, so executed when the package is installed. So if we look at rich, and its path attribute here, we can see that there's a directory inside of site packages called rich, and that module rich then gets put into our sys.modules. And you can see that that's there. So now, this is where it gets a bit complicated. There are actually 2 different types of packages. There are regular packages, which you can really just think of as a collection of files. It's a directory with some subdirectories. And when Python tries to start finding sub-packages, so like rich.console, say, it will start looking in these path attributes here to try and find that package inside there. And that's just basically a bunch of names of directories on your file system. Namespace packages, though, now they're different. They were introduced, I think about Python 3.4, 3.3, something like that. And they use a special type of iterable for path. So rather than it just being a list, it's, there's the iterator interface there, which has the dunder, iter, and next methods and stuff. And so when you're executing this, or going through that iterable, you can pretty much do anything you want. You can access the network, you can download data from lots of sources or the internet, you can try and run rm-rf to see if you can delete someone's hard drive or whatever. Like, there's a ton of scope here to do whatever you want to do. And so if we look what happens then when we try and import some sub-package, so we're saying here, importing some package, some module from some package, Python begins something called a search, and this is kind of a specialist term in the imports sort of spec of how imports work. In Python, it first off resolves the fully qualified name, so some package.some module here, the module that we want to import. And then we use a system of objects called finders and loaders that have to display a particular protocol or implement a particular protocol. And it searches through this hierarchy. So just to look at how this module search might work, first off, Python will look inside of that sys.modules to see if it's already loaded this module. After that, it starts looking through all the different places in sys.path, and then for the modules that it's already loaded, it'll start looking through these path attributes on existing modules to see if it can find on existing packages to see if it can find a submodule inside of them. And I've put this code at the bottom in the closest font I could find to Comic Sans just to show that it's pseudocode. This is not actually necessarily how it works, but these are the places where Python starts looking for your modules. So yeah, pseudocode there. Now, it's worth saying as well that finders and loaders are extensible. you can change how Python goes about doing this hierarchical lookup using these meta paths and sys hooks or path hooks. And if you're doing stuff with this, be very careful you know what you're doing. This is proper dark magic, but it is occasionally important and useful in code that's probably gotten a bit too complicated. Moving on though, inside of just to note what happens inside of a virtual environment, the virtual environment will add a special, you can see here at the top, finder object to this, this meta path. So you have to think, what happens when we install a package? Well, we know now that to make a package importable, we have to copy something into this site packages directory using a module called distutils. And so when we do this pip install rich, we find that, well, rich will just, pip will check that it can find this package rich. It checks the metadata on that package. It tries to get a complete list of all of the packages that it needs to install in order to be able to support the other packages that Rich needs. And if it gets a complete list, it just downloads them, copies them into the right place. Now, you don't really need to know all of how this works to be able to manage your packages. What you need instead are a set of good tools. And I would argue that these tools that we use to manage this, things like PDM, Poetry, pip, pipend, that kind of thing, they're not actually just dependency managers, they're namespace managers. And what do I mean by that? Well, you know, all this different stuff, Python versions, the virtual environments, and then the different kind of modules and classes within them, they're all themselves different namespaces. And so we need a tool to really manage these namespaces. I don't like generally using the Zen of Python, but it's worth remembering that namespaces are one honking great idea, let's do more of them, is right at the kind of very end of the Zen of Python there. So finally, a little quick tour of this tool, PDM. You can find it online. It was actually born of a plan to try and scrap the need for virtual environments, which was PEP 582. I thought that had a lot of strengths, but ultimately it was rejected, and maybe we're not quite ready for changing to this style of working with packages just yet. PDM will now manage virtual environments for you, though, by default, so you don't need to worry about using more than one tool. You can just use PDM. It integrates with PyEn very nicely. And the reason I really like it is it's very standards focused. So rather than tools like Poetry, which kind of invent their own namespaces and ways of doing things at times, PDM will always try and find the most sort of PEP-friendly, kind of standards-based way of doing something. A couple of basic commands. You've got PDM init, which will generate your PyProject.toml for you. Venv to manage your virtual environments. Run is how we run Python code using PDM to make sure all the namespaces are correct. And we also have this add command here. Now, add is important because if we look at what we were doing before when we were doing pip install rich, you're very unlikely to want to install a package that way. What you'll probably do instead is install a bunch of packages for your particular project. I was doing some web scraping the other day, and this was the bunch of packages that it turns out that I needed to use. And if I look at that, maybe the top package there, AIO HTTP, it's an async way of making HTTP requests. Well, if you look at that, actually AIO HTTP requires a bunch of other packages all at different versions. And these versions aren't fixed, they're just greater than or equal to say, this is the minimum version I need. So when pip comes along and tries to find all of the different packages it wants, it will, you'll try and resolve a particular version. But given that new packages are updated all the time, and if we're using the latest versions, like half an hour later, your list of packages could be completely different. So the way that we keep on top of that, using a tool like PDM or Poetry, is to add a dependency, and we can add a dependency to a group. PDM will then work out all of the correct versions of different things and save it in a lock file for you. And then rather than installing files into a new environment, we just sync them at a particular time so you always get the same set of dependencies. And you can also update your dependencies to make sure you've got the latest versions and stuff as well. So returning to our questions, we've looked at where, how we find Python packages, how we make sure we're using the right versions of Python, answering where Python packages come from. Well, I think generally we kind of know the answer here is PyPI, which an alternative name for is going to be the cheese wheel for various different, cheese shop for various different reasons. It's a big project, and it's quite important to know that actually there are a lot of malicious registrations of Python programs currently. I mean, this is an example here, Xbox Live Pi, something you could imagine a kid trying to install, but actually it's designed to exfiltrate Windows secrets. So, it's a bit of a Wild West there sometimes. Now, lots of very clever, very passionate people are doing lots of work here to try and fix the situation of malicious registrations, but I don't know, enterprises should have their own solutions to sorting this out, but we mere mortal users do have tools we can use. One of them is this safety tool, which I think Tomas mentioned the other day in his talk. And so we can run a command like safety check to make sure that we don't have any particular CV registered vulnerabilities inside of our talks, inside of our packages. So yeah, just to conclude, Python packaging, we've looked at how that works. We've seen why we might want to use PDM. Security concerns are being addressed, but it's important to take independent measures for yourself as well. Thank you. And just before I go, I'd like to try and give a shout out for this particular package, which is a little side project I'm working on currently. It does something, check it out, find out what it does there. Look on GitHub if you aren't interested in it. Thank you. So thanks very much. And sorry there isn't time for questions, but do come and catch me. Thank you. Thanks. Sorry, I used to pull it down.
I'm sorry, we don't have time for questions because we've got to set the next speaker up, but I thought he coped very well with fitting into time there.